And we are back with part 3 of the Sick Bike build series, and I'm Mega Man.
Mega Mechatronics.
And we're back with part 3, and we are continuing where we left off in part 2, where I needed to build a shock extension for that cheap shock that I'm using. This is sort of a temporary system until I find the correct setup, the spring and shock for that motorcycle. I'm going to actually have to go with a stiffer spring, but this Chinese model just simply doesn't allow that. So you saw me finish drilling the hole out, and now I am putting a little chamfer on the end so that I can tap this out. So here I'm going to enter with the tap, which is on the tailstock chucked up in a 3-jaw. It's for a drill, but I put the tap in there, and that's going to help ensure that it is pretty much on the center line, something that I can't do by hand for sure. So this is going to allow me to go pretty deep. I guess if you had to do it by hand, you could, but you probably wouldn't get 12 to 25 millimeters deep before you're going to start running into issues, or half to 1 inch deep. So here I'm going much deeper. And you can see that I am turning the headstock by hand. You don't want to, at least I don't want to power tap this thing. I'm not experienced enough, and I don't have the correct equipment. So that tailstock is not locked down. It's allowed to slide on its own as I am cutting it. So here I'm just inspecting and cleaning out the chips. And we'll go through. This is sped up. So I'm going forward and back to break the chips. And this is chromoly, so there's some pretty tough steel. So I found this lathe at a local makerspace. I3 Detroit is what it's called. And it's really affordable, and it's community based, so there's no employees here, so it's really up to you to make it work out. Alright, now we're back in my shop, and I cut off that shaft there that I threaded, and let's assemble this thing. And that lines up pretty well and contacts at the same time, so nothing was too far off there. And I painted it as well. And there we go. We got a little shock made into a big shock. Shocking. Okay, looks like it's time to mock up the bike again, and we'll put this down under my lift. There's a little plumber's crack for your enjoyment, and so I'm going to install the rear brake caliper, the rear wheel, and right now I'm using a stock YZ250 sprocket, so I'm still going to have to get one made a larger diameter, so I'll show you the chain system later in the video here. So we'll get that rear wheel installed, and I am retaining the rear caliper system, even though I will have regenerative braking here. This is a backup for that, or I should say the primary system, and I will have to change the line. I probably only need 6 more inches of brake line to connect up front. And here I got my Marzocchi 888 forks up front, some really heavy duty dual crown pretty much one of the strongest forks you can get for a bicycle. But this is sort of a hybrid motorcycle, so it is pushing it. But I'm not going to be worried. If guys are jumping off cliffs, I'm not going to be jumping off any cliffs, but it'll handle it. So I got that all hooked up. Got the handlebars up there, and those are dirt bike handlebars, so they are pretty wide. And now I'm just playing with the new system. So you can see it doesn't take much to compress that spring. And so when I install it, I basically turn the spring pressure up as high as it can go. It is okay, but again, this is more for a mock-up until I find a better rear shock. So I'm just going to wheel this outside, see how it looks, jump around on it, make sure nothing breaks. And this is still tacked together, but those tacks are holding. And here's the side view. I got my chain hooked up. I got a new 520 chain for this and hooked it up. So what have I been doing? Well, I've been learning how to TIG weld aluminum. I've been doing a lot of practice. See on outside corners, some better than others. Then I started getting the hang of it, started getting the settings correct, and using correct technique, and then I was able to get a reasonable bead on an outside corner. I was starting with this 1/16 inch thick, but these boxes are 1/8 inch to 3/16. So this was a little more challenging, gave me that little bit more skill in controlling the heat and the ends here and things like that. So when I did get to this little bit thicker material, it was a bit easier to work with. Okay, we are back at I3 Detroit, that community-based makerspace. And you can see I'm in the welding area now, and on the left side there you can see a very, very sweet machine, the Miller Dynasty 200 with a water-cooled torch. I am using 16th inch electrodes, tungsten electrodes, and it's 2% lanthanated, and that's something sort of recommended in these community tutorials that we see on YouTube. So 16th inch, that's about 1.5, 1.6 millimeter electrode, and I am sort of at the upper limit, so I can only run these electrodes for so long before they start getting deformed and burnt up. So you'll see me running the final beads on the project boxes here, and this has been sped up very fast, and you can see at the bottom my foot, if you're interested in watching the foot control. So I lay on pretty slow at the beginning, and that helps clean the area, and then move through it. I usually will back off just slightly once I get the puddle going. And here I am changing the electrode, and you can see the dipping action of my hand as well, giving those nice little stack of dimes type of look. So I am following one path, so I'm continuing the same direction, and then I'll come back up to the opening when I get around the corner. So what I found, the settings I'm using are, I'm thinking about 120 amps, running 63 cleaning on the balance, as well as 160 hertz. So I was having some trouble with the material not being clean. I have a stainless brush, and I am using acetone as well, but it seemed like I was having problems until I turned that cleaning action. So that doesn't help the electrode as well. So I'm putting a lot of heat into that electrode. But these lanthanated tungstens are pretty tough. So you can see I'm using a 16th inch, yet I am using a 3/32 filler and welding on that 1/8 inch material, at 3mm to 4.7mm stuff. Alright, well, proof that I'm not fooling around here, let's take a look at what I did. So you can see these start stops, there's a little white there. And the bead is kind of high, but again, I was using a 3/32 filler. Some beads around here, and then down the sides. And then I fabricated these covers. They're sort of like ammo can looking boxes. And I got this silicone dust seal. See, they are a little moist actually from last night, doing some testing. So these boxes do hold water, literally. I filled them with water to the top, and there's no leakage. And then you can see these covers. I welded here. And to bend this really thin, brittle aluminum with the type of brake I was using, it was actually a brake, it was cracking the material. Alright, so I'm going to show you what I was talking about, cracking the material. Here's a little test blank. I did several tests, and I'm just going to show you when you bend this to the 90 degree, it's actually just going to fracture it. So we're going past the ultimate strength on the outside of that part, or the bottom side here. So you can see it completely fails. It does look like a brittle. There is a little ductile, but then you can definitely see it breaks. So I did a lot of testing again before I did it on my actual covers that I cut out. So how I got around this problem was to do some shorter bends. So I'm slowly bending the material. And here I'll take it to about, 45 degrees. Make sure I'm right on my scribe line. So this brake is nice with that this tooling, because if you bend it at the scribe line, you put that sharp part, it's going to be at your measurement. So it is a pretty accurate bend using a brake like this. So that was something I liked. So I took the bend a little farther, and I'll come up here and show you the trick I used to accomplish this. Using this thin, brittle material. So it is aluminum, but the alloy or the heat treat is a little too high. So the trick I used was this autogenesis of I'm not adding filler, but you can see I am quickly pulling up that corner, pulling up that fracture area. So the material is fractured apart, but now I am sort of reflowing those cracks, and those cracks are fixing themselves, you can say. And in addition to that, is I'm using the heat affected zone to my advantage. So I am creating a more ductile material at that corner by going above the transition temperature, as well as filling in those cracks. So then I can complete the bend to 90 degrees with absolutely no problem. There's no problem. I could probably go farther, because again I covered up those cracks, and by going 45 degrees initially, I can reduce the stress on the final bend. And then I have these aluminum hinges, so that made it easier. Just weld it on, put a little spacer here on both of these, and then the latch system here with the gasket down. So I put a little 16th inch spacer here, and these dust covers are an 1/8 inch. So there's a little crush, gasket crush. So I have two pretty much identical boxes here. You can leave these open to dry out. And then what other, well, I'm not done with these. These are about 9% done. So what I have left are these, I cut out some of these tabs, these little hooks. So I'm going to have these hooks on the bottom here, about here and here, and there'll be a shorter version of this. This will actually be installed on the bicycle frame. So these quick detach boxes will sort of slide in here, and they rock into place and lock in. So this shaft will be on the bike using these little mounts here that will go on the frame, on the down tube actually. So these will be on the down tube, sort of like that, and then these boxes will snap into place. The challenge I had to overcome was the geometry of the rear suspension, the rear swing arm, and the way I designed it and the way I made it work. The chain is a little loose, uncompressed, and then as you compress it more, the chain gets tighter. So the problem with that is you need to run the chain a little bit loose to begin with. So to sort of overcome that issue, I created this prototype tensioner right here. Alright, let's jump into Inventor here. This is AutoCAD Inventor 2013. So I have the visibility off on some of these parts so we can sort of show you the components and how I got to this prototype design. So here's that nylon sprocket, and here's a custom bolt that will go there, and that's 6061 aluminum and a couple washers. And then I have a standoff on the other side. Better clear up so that standoff, that'll be the mounting point for the tensioner, and you can see how it is situated pretty much 180 degrees off. And the purpose of that was I had some major clearance issues as the tensioner stroked. You could see how the gear's sitting up really high. That's sort of like the maximum movement there, and then it can go down from there, clearing the parts. And then I added the torsion spring right here. Let's see what else we got here. Got our needle bearing to fit in there. And with McMastercar.com, they're really close to me. It's pretty much one-day shipping, so I'm really lucky with this dealer. As well as they provide drawings for pretty much all of their parts. So a lot of these components, they have 3D models already. So here I have my little custom arm, 3/8 inch thick in this design here. So we can get back, and here's just a stronger spring right there. I'll show you that coming up here. Let's take a closer look at what I built. So I can unscrew that. So it's a 1/2 inch by 13 thread with a little bore for the bearing to slide kind of a press fit. And then here's the problem I was having with purchasing a bolt like this. I need a low profile head on the back. And then I chucked up the sprocket in a lathe, excuse me, and turned down the side to about 270 was the specification, and then I put the little chamfer in there to accept the 520 chain, because the sprocket was made for an ANSI 50, so it will work with the pitch and etc., but you need to mill down that surface, and this was actually enough to chuck it and hold it into place as I cut this nylon. So it was only nylon, and it worked out well. And on the other end I have a bearing system. There's a needle bearing. I think I'm going to go to a little bit tighter tolerance bushing. So here's this little standoff. This will be welded to the bike, to the motor plate. Just a threaded piece there. Then I have a stainless shoulder bolt that the needle bearing rides on here. And you can see the general shape that I cut this out. And I welded on these bosses here to give this a little more thread, match the design. I actually designed this using 5/16, but this is actually 1/4 inch, so I had to add another 1/8 here. And then I had enough room to do a 1/2 inch, and it actually captures the bearing a little bit better. And now to add tension to this, I have these torsion springs. So a torsion spring here. And the way I designed this wants to push up as hard as it can, or within its specifications, so you see that fits on there. So there'll be a provision on the bike where this will be static, and then this one here, which is closer to the arm, will be around somewhere down here. So now you can see the springing action. And I have, this is a little bit heavier one, and I did pick up, for a few bucks, a lighter spring with less coils. So, we'll test those out. And with that, I also needed to create a sort of a chain guide for the drive on the front, the drive side. So this tensioner is going to be sitting on after the drive sprocket when it's there's no tension on it. However, when I do regenerative braking, like engine braking, I need something to stabilize the chain on the other side, because this will go taut because it reverses the torque on the chain, and then I needed a way to secure the front chain. So I designed a simple chain guide, and we're back in Inventor here. So we have this sort of inside plate here, and that will be plastic UHMW, and then here's a block of that same plastic, and then an outer plastic piece. And this is kind of based off the YZ250 dirt bike rear chain guide. So that's going to help the chain maintain its position on the drive sprocket there. And then I added a aluminum plate on the outside to give it some strength, and a few bolts there. So I did some work on the mill last night and cut this down to size, and so it's pretty simple to build this. I have a 1-to-1 template printed out, fairly accurate printers. If you put calipers on here, it'll match those measurements pretty good. So all I will do is cut this out, and go like that. tape it on this piece that I milled down to the dimensions, and then just cut this out in a bandsaw. So these outer and inner plates will be using some more UHNW plastic here, and again we'll use the outer plate will be aluminum to be a little bit stronger, and then I'll use that as a template to cut the two of these shapes out, and these will be sort of the side stabilizers that the chain will rub against. This is really highly abrasion resistant plastic, and it's pretty slippery. Alright, so let's take a look at the tensioner on the bike. Alright, so that's where we're at so far. We still got a lot to go. I don't even know if we're even at the halfway point of the build. There's still a ton of detailing to do, wiring, and not to mention that tensioner issue. So hopefully this is the last time you hear about it, because it works, and then I can move forward with completely welding the frame and then moving on with that and get this project done. So I am still working on the BMS. Let's check out the other electric bike. I have the Nanotex retrofitted. This used to be run on lead acid or SLA. So I have it upgraded to the Nanotex, and I'm waiting on I was planning to use the 3D printer and create an enclosure system for the BMS, but this is working. I have the LCD display to show the cell voltages, minimum cell, and then I need to integrate the low voltage or throttle reduction, and then there's a low voltage cutoff system that I want to test on the code side. So we'll get that stuff done, and if you want to see more videos or continue seeing this sick bike build, don't forget to subscribe. If you like this video, liked what you saw, hit the like button, obviously. Well, I'm Mega Man. Thanks for watching.